Initially, you should select a master cone that is the same size as your master apical file. If you cleaned and shaped to a size 40 file, select a size 40 gutta-percha cone. The master cone must be seated at the correct working length, which is the length from the coronal reference point to the point at which cleaning, shaping, and obturation should terminate. It should also have tugback or resistance to displacement when trying to remove the gutta-percha from the canal. If the cone satisfies these two requirements, then the next step is to take a radiograph to confirm working length. Now we will go over two more scenarios where the master cone that you tried in is either longer than the working length or shorter than the working length. If the cone that you fit is longer than the working length, try cutting the tip of the 40 cone with scissors or choose a larger size gutta-percha cone. If the cone that you fit is shorter than the working length, try choosing a smaller size gutta-percha cone. In either scenario, if the second cone that you tried in didn't fit, it would be a good idea to clean and shape again and then fit another cone. Let's say, for instance, in the last scenario, the size 35 cone fit with tugback but was longer than the working length. We will show you in the following video how you can modify this cone by cutting the tip with a pair of scissors. Since our master apical file was a size 40, we will try in a size 40 gutta-percha cone. The working length was 25 millimeters, but the cone only goes down to 24 millimeters. It is short of the working length. Let's try a size 35 cone. This cone goes down to 26 millimeters. Let's modify the cone by cutting off 1 millimeter from the tip with iris scissors. Try to cut at an angle so that the end is tapered. Measuring with a ruler shows that we need to cut a little bit more to get it to 25 millimeters. Now that it is at 25 millimeters, we will try the cone in again. This cone now has good tugback and is at the correct working length. Sometimes you can have the correct working length, but there is no tugback. In this situation, you can either cut the tip by 0.5 millimeters to see if you can get some tugback. You can also try a different kind of gutta-percha. There are standardized and non-standardized gutta-percha points. Starting from the left-hand side, the non-standardized gutta-percha cones come in sizes ranging from extra fine to extra large. Non-standardized points have a variable taper. The tip of the point can be adjusted by cutting it to obtain an optimum fit and an apical seal. There are also standardized points, which correspond to instrument taper and apical size. These come in different apical sizes of 15, 20, 25, 30, etc., as well as different tapers such as 0.02, 0.04, and 0.06. Let's go over what taper means. Taper refers to the increase in diameter from the tip of the file or gutta-percha to the handle. To explain how taper works, look at this K-file. K-files have a cutting edge that is 16 millimeters long, from diameter 0 to diameter 16. All K-files have a 0.02 taper. That means there's an increase of 0.02 millimeters every millimeter, from the tip of the file towards the handle. Since there is a cutting edge of 16 millimeters on this file, there is a total of 0.32 millimeter increase in diameter. Unlike K-files, rotary files come in different tapers, such as 0.02, 0.04, and 0.06. And manufacturers have made gutta-percha cones to match. Let's compare two different tapers of gutta-percha cones, a 4004 and a 4006. Both have an apical size of 40 at the tip, but the 4006 cone is wider towards the handle. A potential disadvantage of using the larger 06 tapered cone is that the finger spreader will not penetrate as far down the canal. This can result in inadequate compaction of the master cone in the apical portion of the canal, causing a potential deficiency in the apical seal. Also, using a wider cone can result in tugback from a more coronal position rather than at the apex, where we need a good apical seal.